whether it's a storage device, whether it's your machine, whether it's your router that is giving you network currently to connect to this meeting, all of it could be virtualized. All of these services could be used on the internet, and actually they are present somewhere in a data center, and you are interacting with these services over the internet, and you configure them based on your requirement. You can create your own network, you can put your own devices within the network. You can have a virtual machine created which is connected to that network. You can put up a firewall, you can set up a VPN. All of these things you can do in the cloud, right? Then we discussed that earlier, back in the day when cloud computing was not a concept, private cloud or the on-premises environment is what we used to have. Organization used to build a data center for themselves. Only the employees of that organization had access to these data centers. And it's a very expensive process, right? When I say expensive, it's pretty expensive, all right, because the capital expenditure that goes into building a data center is huge. Now, three types of clouds we saw: private, public, and hybrid. Now, I have a question for all of you. If I asked you to tell me which among the three models that we saw, hybrid, and public and private, which one do you think is the most expensive one? Any guesses? If I have to compare the public, oh my God, what happened? Private and hybrid cloud. All right. All of these three clouds will have two types of cost. One is called as a capex. Capex is your capital expenditure. Along with capex, we also have something called as an opex. What is opex? Operational cost. So, for example, if you have bought a television at home, all right. For example, you bought a television, then the price that you pay, let's say you paid 50,000 INR, right? You paid 50,000 INR for that television. Now, this is a one-time cost, right? You only pay this cost when you are buying the television. You don't pay it regularly. You don't pay it, every day or every month. That's a different story if it's an EMI. But even the EMI is the total cost divided into some installments. So that is not what we're talking about. We're talking about 50K paid at once, right? The cost of the television. This is called as capex. This is the kind of initial investment that you do, right? For example, when you build yourself a house, there are bricks, concrete, right? You have to pay for steel and so many things which you only have to buy once. All right, it's not a regular or a recurring cost. That is called as a capex. Any cost that is recurring in nature, repeats itself, is an operational cost. Any cost that is, any money that is spent on keeping your, let's say, data center or your house or your television operational is the operational cost. In case of your television, the cable charges, if it's connected to Wi-Fi, then the Wi-Fi charges, these are recurring. You have to pay them every month. Every month you'll get a cost, right? The electricity, that is also recurring. So whatever electricity your television consumes every month, you have to pay for it. This is called as a recurring cost, right? This is operational expenditure. For your house, electricity cost, your house tax, whatever you pay on a recurring basis. It does not matter if it's a weekly recurrence or a yearly reference or a recurrence or a monthly recurrence. It is a recurring cost. That is called as operational expenditure. In a data center also, you have both capex and opex. Capex is the initial investment that goes into building the data center. All right. So when you're building data center, right, uh, you don't build data center in the public cloud, right? Why? Because Azure, AWS, or GCP, or any other cloud that you're using, they are responsible for building this. Correct? They are responsible for building these data centers for you. So you don't put in the capital expenditure. If Azure is building a data center, I will not go and buy servers for them or networking devices, storage devices. I'm not going to do that for them, right? I'm not even going to help them in building the 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 site where they're going to create this data center. But when I'm creating a private data center, right? When I'm creating a private cloud, I have to pay for everything. I have to pay for all the hardware. I have to pay for all the networking hardware, right? Data centers generate immense amount of heat. So a cooling system, one-time cost only, but I have to pay. So there's a lot of capex that is involved here, right? Building the data center. Operational expenditure will also be there. If my data center is running, it will need network, right? It will be connected to the internet, or else how will people create their resources if it's not connected? I should be able to reach the data center sitting anywhere in the world. I'll show you later in the class today that Azure has data centers all around the world. All right, there are multiple in India. There are data centers in Dubai. There are data centers in the Europe, spread across Europe, North America, South America, a few in Africa as well, in Australia, in New Zealand. So data centers are spread all across the world, right? So for anybody, if I can go ahead and create a resource in a data center present in US, Azure gives me that opportunity, all right? Or it allows me to create a resource anywhere in the world, right? So how do I connect to those resources? If I have created a virtual machine, let's say somewhere in US, I should be able to connect to that virtual machine in US, right? And how does that happen? That happens through the network, right? So internet has to be there, electricity has to be there, right? What else? Can you guess any other operational cost for a data center? Anybody wants to take a guess? Any other operational cost for a data center to operate? Anyone?
Memory, space.
Uh, Memory, space. See, that will come into the hardware, right? If you're buying memory or
You also
compute for
take
your
it, right?
About security.
security, yeah, physical security, you need to have security guards in place, right? Your security is also gonna be. What else?
Real estate
What
cost to
about
build it.
the cost to build
The
it
real
will be a
estate
capex
cost to
cost, right?
build it.
The
You
cost to
also
build
need
it,
a real estate, right?
yeah, real estate will be a capital expenditure, right? Because you only buy land once and it's
Yeah.
done, correct? So that's a capital expenditure. Salary to the employees.
Mm.
If you're running a data center, you would need administrators, you would need security administrators, you'll need database administrators, you'll need storage account configuration people, right? So all of these people will need some salary, which is an operational cost. So recurring cost that you pay every month is an operational expenditure. Capital expenditure is the cost that you pay only once and then you don't have to pay it again. Now, my question to you is, which of these clouds that you see here, whether public, private, or hybrid, which one do you think is the most expensive one?
Private.
Private.
All right. So majority of you are saying private, right? Now let's take a look. In the public cloud, do I have a capex? Do I have capex to pay in public cloud?
No.
No.
Capex is not there, right? Because it is the responsibility of Azure, AWS, or GCP to take care of the capital expenditure. Do I have an operational expenditure here in the public
Yeah,
cloud?
it's that use based on your
It's
usage.
it's the rent that I'm paying, right? So my
Yeah.
rent is on a monthly basis. So I'm paying my rent. So my OPEX here is the rent only, right? Coming to the private cloud. Do I pay CapEx?
Yes.
I do pay CapEx. Do I pay OPEX here?
Yes.
Yes.
Obviously, right? If it's my data center, I will need to pay for the network, the electricity, the salary, and everything. And if I have built it, I have to pay for the CapEx also, right? Coming to hybrid. Hybrid is what? A combination of public plus private.
But it also depends how much you're using it, is that?
Exactly. It does depend on how much you're using. If your private data center is, very small and an insignificant cost, then obviously you can compare it. But for the comparison, right, we try to keep it all the same, right? So the same amount of compute and infrastructure that you have in private, the same infrastructure if you get it in public, versus the same infrastructure of both of them, right? The public and private in the hybrid mode, right? So here you have to pay for capex also, you have to pay for opex also, and you have to pay the rent also. All right. That is why hybrid cloud environments are most expensive, and they're also the most complex cloud environments, right? Because this is where we have to, bring into the account the communication between my on-premise environment and my cloud environment, right? So it is more complex to set it up. Clear? Make sense? Any doubts?
No, thanks, Reese.
Makes sense, right? Hybrid is where you will have private and public both, hence the larger cost, right? And the cheapest is the public. This is the cheapest one you have. The most expensive hybrid. All right. So that is about the cost. Now, next topic that we're going to discuss is the various cloud benefits that you get with cloud computing. Now, the very first benefit and the most important cloud benefit, all right, is the benefit of availability. What has happened? One second, guys. Yeah. So this is the capex and the opex that we discussed. Capital expenditure is the upfront spending of your physical infrastructure, right? And capex is something that reduces in value over time. So it's just like buying a car. If you buy a car over time, it reduces in value. If you buy a mobile phone over time, it reduces in value, right? So we'll go back there. Just trying to. Okay. Yeah. Don't know why. The very first benefit, the cloud benefit that we discuss, is the benefit of high availability. What does high availability mean? In cloud computing, anywhere you go, any cloud you go, the concept of availability is, I would say, the most important, right? That is also one of the reasons why people want to switch to cloud, because of the very high availability that it offers. High availability means if you have deployed an application on the cloud, if you have created a database on the cloud, if you have created a virtual machine on the cloud, all of these resources are always accessible. They don't go down. Can you give me any example of low availability? Anybody has any example of low availability that they've experienced? Have you tried booking IRCTC tickets during Tatkal hours? Yes or no? Anybody who has ever tried that?
Yes, Reese.
Yeah, the maintenance window actually.
Exactly. It's mostly not running. The website is down, correct? And that creates a very bad user experience, right? So we don't want to, create a very bad customer experience or the user experience for our customers. Therefore, companies want very high availability. Their resources should not go down. Now, I'm not sure many of you would have heard about it, but last year, Azure and AWS had a really big outage. Anybody remembers? AWS had gone down. After that, Microsoft also went down. Azure also went down, right? And people were not able to access their resources. People were not able to access their whatever infrastructure that they had created. People were not able to access the Microsoft applications, Teams, Outlook. It did not work, and it creates chaos, right? So you do not want that. You want your applications to be always up and running, always available to the customers, and therefore cloud offers high availability. And you know how it does that? It gives you something called as a SLA. Anybody knows what SLA means?
Service level agreement.
Correct. it expands to service level agreement. What is a service level agreement? It's a guarantee. All right. It is generally given in percentages, and for many services, Azure gives a service level agreement of 99.99%. All right. What does 99.99% mean? Or 99.90 also it gives. That means that in a month, in the 30 days of the month or 31 days of the month, or whatever the duration of the month is, the application will be up and running 99.99% of the time. All right. It will only go down for 0.01% of the total time of that month. And if it goes beyond that, we will refund you your entire cost of that resource. All right. So they'll not charge you for that resource if the SLA is broken. Hence, Microsoft, makes sure that the SLAs are always met. Now, there are various strategies that they, use. For example, if you have one virtual machine, they will create three and place them in different locations. All right. So if one location has gone down, one location has a network outage or an electricity outage, your machine is still running in some other location. Right. So it never goes down. Similarly, with your data, they will never store all of your data in a single device. What if the device, gets corrupted? Right. So what they do, they put your data in multiple devices so that even if one device is gone, the other two devices are always up and running. Right. So that is high availability. Low availability also you understood, when the application is not reachable, the application is not up and running, right? Similarly, you would have experienced with a few of our government banks as well in India, right? You try and go there, you get your work done, and they'll get back to you saying that the server is down, we cannot help you, right? So that server down means there's an outage, there's low availability, correct? Second is the concept of fault tolerance. Fault tolerance as a cloud concept or a cloud benefit means that my cloud infrastructure is always up and ready to fight any fault. All right. It has a tolerance against the fault. That means if any fault occurs, there is a backup strategy in place that will help me up. For example, I told you about the storage locations, right? When you store your data on the cloud, it is not always stored in a single place. It is generally stored in multiple places. And when you talk about cloud computing, especially in Azure, three is a magical number for you. All right. So there are various concepts that we'll cover on the availability of application, because uh, this is what SREs generally deal with, right? Your site reliability engineers, they focus on availability of applications, focus on availability of the servers, the virtual machines, and everything, right? And when they do that, three is a magical number, because in most of the scenarios, in most of the resources, Azure will create three copies. Whether it has to create copies of virtual machine, it will create three copies. Whether it has to create copies of your data, it will create three copies. How it is storing the three copies is different. Sometimes it will store all the three copies on different devices in the same data center. That is one level of high availability. The higher availability would be that you created multiple copies and stored it in multiple data centers, one in India, one in US, one in Canada. That is even higher availability, right? So like that they do it. So fault tolerance means any fault, when it has to happen, there is a backup in place if the fault happens. For example, internet. Every data center needs internet. And let me tell you, even these data centers use the same internet that we are using as customers here in India. At least I can tell you about India. The others I'll show you in the class how you can find out which all data centers have which all internet service provider ISPs, right? So my data centers in India can use Airtel, they can use Vodafone also, Vodafone Idea, they can use Geo as well, right? They can use ACT as well. And there are some other companies also that provide these the internet to these data centers. And these data centers have very fast internet. All right. They have a dedicated lease line. And they don't get 100, 200 Mbps. They get in Gbps, 1 Gbps, 2 Gbps. That is the internet speed that these data centers get. But always, any data center will not have just one internet service provider connected to it. They will have multiple. Why? If one internet service provider goes down, They still have the other two up and running, working. Similarly, for power, they will have multiple power backup options. They'll not just have one power backup, they'll have multiple power backups. So even if the electricity outage is there, one backup is running. If that one backup also does not work, the second backup runs, then the third backup runs. Multiple backups are there. That is called as fault tolerance. Cloud is created in a way that it fights any kind of fault. All right. Then we come to scalability. Cloud offers you scalability in your own system. If I'm sitting here, all of you have a machine, all of you have joined this meeting through either a desktop or a laptop, correct? You have it. Some people may have 8 GB RAM, some people may have 16 GB RAM, correct? Some may have 32 GB RAM. Anybody who has a higher RAM than this? Maybe or maybe not. Some of us will have, more CPU, some of us will have lesser CPU, but there is a limit to the highest CPU that we'll get, right? The computing power that we'll get. Somebody might have 1 TB of SSD storage, somebody might have 2 TB SSD storage in their system. But can I scale this indefinitely? What do you guys think? Scaling means I have a 8 GB RAM machine, I want to make it 16 GB RAM machine. Can I do that? Yes, I can do that. I can even try to, convert a 16 GB RAM machine into a 128 GB RAM machine. But can I take it to something around 512 GB? Is it
No.
easy to do? No, right?
No.
Similarly for CPU, if let's say I have two virtual cores or 2 cores of CPU, I can make it four, right? Or I can try to make it four. It may not work. I cannot make it eight. I definitely not 100 cores of CPU, right? Same with the storage. I can have 1 TB of storage, 2 TB of storage, maybe till 10 TB I can go. But can I go to 1,000 TB? No, right? So that kind of scalability is not available on my machines, and that is a problem. That we experienced in the previous generation of our data processing systems as well. We used to call them monolithic systems, right? You would add so much of compute, you would add so much of storage, you would add so much of memory into one machine that after beyond a certain point it becomes impossible to scale them, correct? But in cloud, I can scale my machine. The laptop, the virtual machine that I create on the cloud, I can very easily convert it from an 8 core CPU to 108 core CPU. I can do that. All right. I can increase the RAM as much as I want. I can have the storage as much as I want. Right. What kind of scalability is this? When you have a machine and you increase the capacity of that machine, what is it called? Horizontal scaling or vertical scaling? First of all, let me tell you, there are two types of scaling. There are two types of scaling. One is horizontal scaling. Sorry, one is this vertical scaling that you see on your screen, and the other one is the horizontal scaling. When you have a machine
Vertical scaling.
and you increase the size of this machine, this is called as a vertical scaling, that you're increasing the size of an existing solution. Correct? That is called as vertical scaling. This is your vertical scaling. Horizontal scaling is something that you see in Apache Spark, Hadoop, Databricks. What is horizontal scaling? You had one machine,
Clusters.
you added more machines in the cluster, right? So when you increase the size of an existing instance, that is vertical. When you increase the number of instances altogether, that is horizontal. All right. So this is my horizontal scaling. Clear? So cloud helps you with both vertical scaling also and horizontal scaling also. If I have created a virtual machine with 4 cores of CPU, 16 GB RAM, I can today go ahead and convert it into a much bigger unit, right? Clear? All right. Now there is a very similar term called scalability here. All right. Oh, sorry, elasticity. Scalability we did. Elasticity. Elasticity and scalability, both of them go hand in hand. They more or less mean the same thing. The only difference is elasticity talk about a resource capability to scale itself, scale automatically. All right. And cloud gives you, or cloud computing gives you the benefit of auto scaling. All right. You have to create certain rules that if my CPU utilization is, let's say, 80%, add one more CPU. Right. So now two CPUs are there. Average will be 40% load on each of them. Right. If it reaches above a particular point, add one more CPU. If it reaches above a particular point, if my RAM utilization or memory utilization is above a particular point, add one more compute. All right. So auto scaling is also present in cloud, technologies such as Azure. We'll discuss just one more, which is, the global reach over here, and then we'll see to the other section because some of it will be, since we'll be starting the class again from tomorrow. So we'll go through this once again. Global reach is the concept that says that cloud is present everywhere. Now, my question is, why is cloud present everywhere? Who wants to answer that? Why is it required to have data centers in India, in US, in Canada, in Europe, in Middle East, in Australia? Why is it required to have so many data centers around the world?
Disaster recovery in case there is any emergency.
Disaster recovery could have been done with multiple data centers in US itself, right?
Internet disconnect between the country.
Probable reason, yes. The most important one that you're missing out on is the latency. Correct? If I'm sitting here in India and I'm connected to a machine in US, it does not matter how fast my internet speed is, I'll still get some latency. Correct?
Yeah.
Even minimal, there would be some latency, right? The second one is something that I would explain it to you with an example. How many of you have used, somebody yesterday was telling me American Express, right? Amex cards. Anybody uses Amex card over here or a MasterCard? These two?
Mastercard.
Yes. Back in 21, the government of India blocked American Express and other companies issuing MasterCards from issuing these two cards. All right. I'm not sure if anybody applied back in 21, but if you did, you would know. American Express was told by the government that you cannot issue any new cards in India. Same for MasterCard. The banks that were issuing MasterCards were told not to issue any new MasterCards in India. The reason being, both of these companies were storing the data of Indian citizens, the transaction data of Indian citizens outside India. They were storing it in US. And the government has just come out with the new IT regulations, which said that any essential information or personal information, right? Such details, transaction information, right? Critical information has to be stored somewhere in India. You cannot store it in US. All right. And these companies, they did not have the infrastructure present in US, in India, sorry, to shift their entire operation in a single day into a data center in India. So I think they took almost 1.5 years to comply with this notice from the government. And after 1.5 years, I think in October 2022, they were again issuing new cards in India. But for that, they had to make sure that they comply with the local regulations. So many companies have their local regulation. How many of you heard of this local regulation called GDPR?
The data protection. Global.
General Data Protection Regulation.
Yeah.
Where does it apply? It applied to all European countries, right?
Mm.
So European countries have put out this standard called GDPR, or a General Data Protection Regulation, that mandates organizations from not storing any data of a European citizen outside Europe. All right. So if you have a French citizen, their data could be stored somewhere in Italy, but not outside Europe. They cannot store it in US, right? So many countries, many regions will have this particular regulation, such regulations where they want to protect the privacy and the data of their citizen. China being, the biggest example over here, but China is on a completely different tangent and on the extremities of it, right? They don't even let Azure operate in China. Correct? So we'll talk about it. There is a complete different section in the course about it. Maybe today only we'll see. Right? So global reach is required because first of all, we want to reduce the latency. Secondly, we want to comply with the local regulations that has been laid down by the authorities of that particular region, right? If the authorities have asked us, for example, if tomorrow, India tells everybody that you are not allowed to store any data, whether it is personal or not, outside India, there will be no data flowing outside of India. What do? You need infrastructure in India. Every company has to now build infrastructure within India. Many of them will not have the capacity to build their own data centers or to build and manage their data centers. So what do they need? They need cloud service providers. They need Azure. They need AWS. And Azure and AWS will then have to build more data centers in India to meet the demand. That is how it works. Security, we all know there are many things. We'll discuss security in depth during our session, and agility and disaster recovery also we'll discuss. Uh, this is what I wanted to show you, right? So certain topics we are doing, we'll revisit these topics, obviously, once we start with the session tomorrow. Now, we need to talk about the architectural components. Until now, whatever we have seen, right? Uh, there's one more thing called infrastructure as a service, platform as a service, and software as a service that we cover. So those things, they are a part of your simple cloud computing. They're common across all. Infrastructure as a service is I would say, concept in Azure also, AWS also, GCP also, and any cloud provider, you'll see infrastructure as a service as a concept, right? Platform as a service, software as a service, you'll see. So that we'll, do tomorrow in the regular class. I wanted to bring you to the architecture of Azure and show you how Azure is built, right? So now, if I show you, this is what a data center looks like. All right. So this is one of the data centers which is present in Ireland, Dublin, right? And it's a top view of it. Obviously, it's not open as you see on your screen. It is closed, and from inside, it looks something like this. All right. What you see on your screen are called as racks. Correct? Racks will have multiple servers on them. All right. Racks are used to store servers. In Azure, we don't call them racks and servers. We have a different name for them. All right. Racks are called as fault domains. Servers are called as update domains. All right. Racks are called as fault domains because if there is an electricity outage, if there is an internet outage, it will affect the entire rack. All right. It will affect the entire rack. Therefore, any fault that happens occurs on the rack level. Whereas when you have to update the servers, right? There are moments when you need to update your servers. So whenever you do that, you have to go sequentially. You go one server at a time. Correct? So update happens on the server level, right? If you want to update a server, you have to update a single server first, then go to the next one, then do the third one. So fault happens on the rack level, updates happen on the server level. Hence, fault domains and update domains. You will not see it written as fault domains and update domains everywhere. You might see it written as FD or UD. All right. So this is how it is built. Yeah, inside the data center. So there is a rack, right? And each rack will have multiple servers on it, like this. Right. Now, these are called as Azure regions. So the concept in Azure is that whatever we have in a single place is called as a region. If I zoom this, one second. If I zoom this part, you'll be able to see South India is a region. Central India is a region. West India is a region. Then you have UAE, you have Korea, China, Japan, Australia, New Zealand, South Africa. Here you have North America and the Canada, Mexico, and the US data centers or regions, right? I'll tell you a very important thing right now. Data center and regions are two different things. All right, I know it may sound a bit weird, but that is what it is. A region can contain more than one data center. All right, so if this is your region, you can have multiple data centers or multiple data center buildings within a region. All right, generally, one building is considered to be one data center. All right, so within a region, I can have multiple data center buildings. The thing about Azure is that a data center is called as a zone. All right, so this is your zone number one, this is zone number two, this is zone number three. All right, so within a region, I have multiple data centers or multiple zones. Make sense? That is how Azure is built. Eventually, you will see in most of the regions, you will find more than three or more than three, zones present, right? For example, if you take India South, that is in Chennai, it has three data center buildings. Similarly, all data centers in all regions in India will have three data center buildings or three zones in them. All right. Why is it created? You will understand it much better when we talk about the availability. How does it help the availability? All right. But as of now, just remember a region is a place within a geography, right? For example, India geography or a South, we call it Southeast Asia, right? So Southeast Asian geography or Europe geography, you have multiple regions. India South, which is in Chennai, is a region. India West, which is in Mumbai, is a region. India Central, which is in Pune, is a region. Within the region, I have multiple data centers. All right. So that is how it is built. Let's move on. Now, one thing to, or let's do one thing. Yeah. One thing to focus here on is that if, let's say, I'll zoom in again over here. Is this one second? Hmm. If, let's say, South India region has gone down, all right, for some reason, there is a natural calamity, let's say there's an earthquake or a flood or something, God forbid. But if South India region has gone down, right, I would want to replicate the data and the services to some other region. Yes, I should have a backup in plan. Where do I take the workload from South India? Where do you think it goes? Central India, Southeast Asia, East Asia, South Africa, North. Where will I take it? If South India has gone down, do I take it to Central India, or do I take it to East Asia, or somewhere here in the South, or to a different region altogether? Where do you think?
Central India.
Central India, right? Because it helps me in two things. First of all, any local regulation, it does not break it. If the government has laid down law that the data should stay in India, then it helps me with all the local regulation. Second is the distance is short, right? And I'd be able to easily move my data between these two locations. So that is correct. Do I wait for a natural disaster to make this decision, or should I wait for a natural disaster to make this decision? What do you guys think? Is it a decision that should be pre-decided, or is it something that we should decide on the spot when something has happened?
It is pre-decided.
Pre-decided, right? You'd always want to be prepared for anything that may happen to any of the regions. So that is why we have the concept of region pairs. Now, if you see the definition of region pairs, it says that the distance should be at least 300 miles. 300 miles roughly translates to around 500 kilometers of distance. And that is because if, let's say, there's an earthquake and you have two regions, let's say 20 kilometers apart, what are the chances that the earthquake will destroy both the regions? Pretty high, right? So therefore, you want a safe distance between these two regions to, classify them as a region pair. You don't want them to be so close to each other that the natural calamity affects both of them, and then whatever backup you had decided, you cannot even do that, right? So it's already decided. The thing is that you should have at least 300 miles of separation between them. Automatic replication of services from region 1 to region 2 happens, and it's a bi-directional connection. All right, it's not that if India South has gone down, I go to India Central, but if India Central goes down, I don't know where to go. No, it means when the pair has been created, I go to you, you come to me. Bi-directional. All right, not unidirectional. So now if you look at the picture here, there is one very lonely data center in this picture. Can you guess which one?
Brazil?
Brazil
Brazil.
South. The problem with Brazil South is that it does not have a nearby data center. So what does it do? So this is an exceptional situation. If any one of you is, planning on writing the AZ 900 exam, which is the certification for Azure Foundations, all right? So there's a Azure Foundation certification exam to specify your skills or to showcase your skills that you have the foundational understanding of the Azure platform. So this is one of the most frequently asked question there. Which is the region pair for Brazil South? And that is because it's an exception, right? Like in back in the day when you were studying chemistry, uh, we used to learn a lot of exceptions there, right? Similarly, here also they focus more on the exception. If you know the exception, obviously you know the rest of the things, and you don't have to remember them. You don't have to by heart them. But Brazil South is paired with South Central US. If you see here at the bottom of your screen, if you see, one second. This Brazil South here is in paired with South Central US, but this is a one directional connection. All right. So in this scenario, we don't have South Central US sending its resources to Brazil South and Brazil South sending its resources to South Central US. Why? South Central US is already a pair with North Central US. If you see the first one, South Central US is already friends with North Central US. So these two are the best friends. If anything happens to any one of them, they go to each other. But Brazil South is like that third friend. If anything happens to Brazil, it comes to South Central US. But if anything happens to South Central US, it does not go back to Brazil. It goes back to its best friend. All right. And even in cases of, um, rolling out the updates, we roll out these updates sequentially in the region pairs. All right. Because let's say India Central and India South have hosted an application, right? Both of them are hosting one application. So you don't want to, deploy the newer version of that application on both of these locations at once. Why? Because you want to, deploy it in one of the locations and see whether it is working fine or not, and then only move to the second location, right? That is also something that it helps with. Now comes the sovereign regions, right? Most of the
Yes.
regions that you saw in Azure, yeah, go ahead. Somebody had a question.
Yeah, Santosh here. So, if you can just go back to the previous slide, right? Just have one question. So, again, if both Brazil South and South Central US goes down, so well, the Brazil.
That is very highly improbable. It's not going to happen. All right. For one region to go down, it is next to negligible chances.
Okay, okay, but anyway, the Brazil data will not be copied to North Central, right?
No, no.
Okay, okay, yeah, sure. Thanks.
All right. Now, all the regions that you saw here, most of these regions are accessible to you. If I go today to Azure and try building or creating a virtual machine in East US, I'll be able to do it. In Canada East, I'll be able to do it. UK South, I'll be able to do it. East Japan East, I'll be able to do it. India, I'll be able to do it. But not all regions are available to me. Some regions in Azure are reserved for a particular entity. When I say entity, it could be a company, it could be an organization, it could be a government also, and it could be a country also. All right. So to explain the sovereign region to you, there are two examples. First is the sovereign region of the US government services. US government wanted a data center, but they knew that they do not have the expertise to create one data center, all right, or even manage it. So what did they do? They asked Azure, build us a data center, manage it for us. All right. But only the people who we authorize to work in these data centers will be able to work in these data centers. Secondly, this will not be available to the public in general. This data center will only be for the US government's need and their usage, right? So this became kind of a private cloud. All right. So this is only for the US government people. Only the authorized people can go and create resources within this data center. The second example of a sovereign region is China. Now, as I said earlier, China is in a very problematic situation when it comes to for outsiders to do business in China. They demand either of the two things. One, they tell you partner up with a Chinese firm, and then that Chinese firm will operate on your behalf within China. All right. This is the first option that they give you. The second is you do a complete transfer of technology. Let us first understand what you have, the product that you have, how it works, and everything, and then we'll let you operate. That is why you'll not find WhatsApp in China, you'll not find Facebook in China, they do not allow YouTube in China, right? Most of the outside companies, they don't operate in China, they have their own products for themselves. Correct. But Azure wanted to build data center in China because it has a huge market, it has a huge potential, right? So Microsoft partnered up with a Chinese firm. They took the first option, partner up with a Chinese firm, set up a joint venture, and then you can operate. So they partnered up with this firm called 21YNet. All right. And 21YNet operates and runs Azure cloud services within China. All the data stays within China for compliance, and only Chinese citizens can use it. You and I cannot go ahead and create a resource in the China region. Clear? Make sense? Yes or no?
Yeah, thanks, Rajesh.
Yeah. All right. So now I think we'll stop here. We're also reaching the 9 p.m. mark. Uh, we'll stop the demo class here. We'll continue from here, and there are some topics that we'll cover from the previous sections also, like the cloud service models and all those things, which we'll see tomorrow. Uh, as you are already aware, the free demo class was until today. From tomorrow, we'll have the regular paid sessions, and you can get in touch with the backend team, to know more about the course, the structure of the course. If you have any doubts, you can get in touch with them, or we will be taking up questions now also. So if you have any question, please go ahead. I'll be more than happy to answer it for you.
Yeah, hi Shreya. Thanks for the session. Actually, I've already enrolled, and I
Mhm.
wanted to understand if you wanted to start from the beginning itself for the certification. Do you share
Right.
any other material apart from what you're teaching, like any other book we need to go through, or any other resources where we need to go through and prepare ourselves for it?
Yeah, absolutely. That is what I'm telling you, right? I'll be sharing the entire Microsoft Learn documentation with you.
Okay.
So it's a complete end-to-end. It consists what I have taught and beyond that also, right? For the certification, AZ 900, DP 900. All right, these two certifications, the Azure Data Fundamentals and the Azure Fundamentals, you don't have to refer any other textbook. All right, there are just some small sections, the security and the identity sections, which are not important for data engineering purpose, that I'll let you know where you can prepare from. But rest, 80% of those syllabuses will be covered in the class itself. So you can go ahead and write both of those certification exams.
Got it. Got it. And there's a one website you just told. Can you show me that? Where are we talking about that? If you don't mind, please.
Microsoft Learn is where Microsoft creates all of its documentations. All right, so I'll
Oh,
show you. Any documentation from Microsoft on a Microsoft product is present on MS Learn.
Okay.
All right. So if let me just share it. So like this, if you just search for AZ900, right? You go to this Microsoft Learn website. So if you open it, you will have an entire learning path over here. So there are 3 modules over here, right? So you can continue to the course or you can just open one of them and describe the cloud computing, all right? Azure fundamentals, shared responsibility models. So all of this will cover,
Got it.
all right? The benefits also that we saw, high availability, scalability, reliability, predictability, cloud service types, the infrastructure as a service, platform as a service, software as a service that I was telling you, right? So this will be
Yeah.
covering tomorrow. So all of this will be
Oh.
covered in the class. So this is kind of a documentation for a particular certification. All right. Apart from this, also, if you want to learn anything, let's say you want to learn about Azure virtual machines, just search for them. And on Microsoft Learn, you will find the overview of Azure virtual machines.
Okay.
This
Got
contains
it.
complete documentation of it.
That will be the certification.
Yeah.
And for the data engineering certification?
Same thing. See, for data engineering certification, as of now in Microsoft, we don't have any certificate, right? We have certifications present on Fabrics for data, but the DP203 that was there for the services that we are using was discontinued by Microsoft.
Oh, okay.
Hmm.
Okay, got it. Thank you.
Yeah. Others, if you have any questions, please go ahead. You can find the contact details in the chat window. The mobile number that you can reach out to on WhatsApp, the details about this course. And apart from that, if you have any questions, please go ahead. It's gonna be 5 days a week, 1 hour, 15 minutes of lectures every day. All right. So if you do not have any questions here, thank you so much, everyone, for joining in. It was a pleasure having both of you, all of you. Yeah, somebody said something.
Can you hear me? Parveen
Yes,
Pal
I
this
can
side.
hear you. Hi,
So
Praveen.
you mentioned that Monday to Friday and 8 p.m. to 9 p.m. /
Yes.
7 a.m. So it will be both morning and evening.
Yes, so we are starting with both the batches, morning batch also and evening batch also. So whichever suits your requirement, you can join that batch.
But it will be repetitive session. Like if I miss in the morning, I can
Same
do
thing.
in the evening.
We'll be doing the same thing in the morning also and in the evening also, just for your convenience, because we have people from outside India also, who have regularly attended our training. So for them, I think the morning session works best. For Indian people, I think the evening session works best. So it's a mix, right? Somebody in India might want to do it early in the mornings from 7 to 8. So it's just to cater to everybody's need.
And person can switch to morning to evening. There is no problem.
Uh, I think
Yeah, because sometime like if we have a meeting or some other like support work, then it's
that is what I'm
difficult.
telling you. If you have a meeting, we'll be recording the sessions, every day. But we cannot guarantee that both the sessions will be at the
Would be the
same
same.
point every day, right?
Yeah.
Actually,
Have
also
separate.
the morning batch will consider based on the batch size because most of our Indian students wants to have in the evenings only. So based on the batch size, we will start the morning batch. Otherwise, evening only mainly this one.
Yeah. So primarily it's for the evening batch only. But if you have a good number of registrations for the morning batch also, then we'll consider it.
Okay.
But anyways, as we've repeatedly told, every day's recording will be made available to you. So before coming to the next class, if you have missed out due to a particular emergency or something, you can always revisit that lecture.
Yeah.
All right then. Thank you so much, everyone, for joining in for the 2 days. I hope to see you in the session. And as I said, it was a pleasure having all of you here with us. Thanks a lot, everyone.
Yes, Shreyas, we can wind up the session if there is no question.
If you have any questions, you can always get in touch with the backend team, right? Thank you all.